We're going to look at an example of how we can use the bar chart to find more advanced probabilities. And we're going to look at an example with throwing dice. And the situation is we have a fair cubical die, right? So an ordinary die, 6 faces. And we have a fair tetrahedral die, so that's a die with 4 faces. And the discrete random variable s is defined as the sum of the numbers on the 2 dice. So we'll start by decoding a bit of text here. Fair means that there's an equal chance of each face landing face up, or face down in the case of the tetrahedral die. Cubical means that it has 6 faces and tetrahedral 4 faces. Discrete means that only distinct numbers are possible. It's the opposite of continuous. So we're starting out with discrete variables here. So a die can have the values of 1 or 2 or 3 or 4 or maybe 5 and 6, but it cannot be 2.2, for example. So that's what discrete means. Random variable means that the result can vary, and it's random every time you throw. Okay, we want to start by setting up a sample space diagram because we're dealing with two dice here. So let's see how many results we can have. Now it doesn't matter which die you have on each axis here, so the result is going to be the same, but you have 4 numbers one way and 6 the other way, so if you multiply that, that's 4 times 6, that's 24. So the total size of the number of possible outcomes here is 24, and we can just begin to fill in the numbers. I mean, we're talking about sums of numbers here. It's not always sums, but in this case it is. So we'll just get all the numbers in like that. And that's our sample space diagram. And the first thing we're asked to do is to create a table of values. So these are the possible values that this variable s can take. So we use a lowercase s for the different values, and they are, let's see, s. They can be 2, 3, 4, 5, 6, 7, 8, 9, and 10. And now we can look at the probability of each, and that would be the probability that capital S is equal to the lowercase value of S. So for 2, that's going to be, let's see, okay, we can just mark that off here. That's 1 out of 24. For 3, it's 2 out of 24. And for 4, it's 3 out of 24. For 5, it's 4 out of 24. And it remains for 6 as well. And for 7, it's also 4 out of 24. And for 8, it's 3 out of 24. For 9, it's 2 out of 24. And for 10, it's 1 out of 24. And we're going to set up the bar chart for this as well. And it's no coincidence that this is a coordinate system with first and second axis, because this is a function. This is a function of of S. And that function happens to be a probability distribution. So we could write f of S, or we could also call it the probability that capital S equals lowercase s. So if we were to draw this, it would look like this. Let's see. So that's 1/24, and then 2. I'll just fast forward a little bit. It's 4 and 5, 6, 7, 8, and 9, and 10. So this is the probability distribution represented as a bar chart. And now we're going to represent this also as a function and an expression that we're used to seeing for functions. And this is going to be a piecewise function. And a piecewise function, you might remember, is a function that looks different depending on the domain. So, this is a function that changes characteristics depending on the variable that we're talking about. So, if we start from 2 and going up to 4, we can see that it follows the same pattern, the probabilities. And then it's flat between 5, 6, and 7. So here it's different again. So we're going to need an expression for that area as well. So that's going to be between 5 and 7. And then finally it changes again between 8 and 10. Like this. And also S is a natural number. So we'll start by looking at how these values relate to each other. So these are the variables, the values of the variable S, and these are the function values. So how do they relate to each other? Okay, so it seems like we have a sort of pattern here where if you take S and you subtract 1, then you get the numerator for that fraction underneath. So 2 minus 1, that's going to be 1. And if we divide that by 24, then we get the function value. Now, for the midsection, we can see that the function value doesn't change. And what type of function do you know that where you have functions values that are constant? Well, these are linear functions where you have a horizontal line. So no matter what happens to the variable, the function value stays the same. So this has to be a constant number, and that number is 4 divided by 24. Now for the last bit, and this will get easier with practice, I hope. The last bit. We may notice that, if we add the variable s and the numerator for each fraction, we get the same number, so we always get 11. So 8 plus 3 is 11, 9 plus 2 is 11, 10 plus 1 is 11. And so if I were to write 11 minus s, in the first case that's 11 minus 8, that's 3, and that's how we get the function value. And this will work for the other two as well. So 11 minus 2 is 2 24ths, and 11 minus 10 is also 1. So that should work for all three. In the next video, we'll find some probabilities.